You can get at a single character in a string. And when I say get at, perhaps I should use the word access. You can access a single character in a string using the subscript operator. And here we have a picture of the subscript operator, the left square bracket and the right square bracket. So the two of these together make up the subscript operator. Remember, it's actually considered to be an operator, just like the plus sign, the minus sign, etc. Here is an example of the syntax that you would use to access an index in a string. So you would have either a literal string or a variable that represents the string, followed by the left square bracket, and then inside you would have an integer or an expression that resolves to an integer, and then finally close it off with the right square bracket. Right now, notice we have a note here. The index is usually in the range of 0 to length of string minus 1. This is an important thing to regard. All right. Just as we saw with the range, a string starts with index of 0, right, or the value of 0, and goes up to the length of the string minus 1. It's really important never to try to access an index of the length of the string, because that's going past the end. Right. So, for instance, we'll look at some examples here. All right. We have name is assigned the value of Alan Turing, and if we wanted to access the A, name sub 0, and this is how you would refer to it when you use the subscript operator. You just say the literal in front or the variable name, sub, and then give the index, the value of the index inside. So name sub 0 is A, because A is the first letter in the string. It has index 0. If I were to look at name sub 3, I would get the value N. 0, 1, 2, 3. That's how I get the N. If I were to look at name, length of name, right? So here I have an expression that resolves to an integer, this integer being the length of the string. So what is the length of the string? Well, let's count that. And we don't start counting from 0. We start counting from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 characters in this string. So going back to this note above, this string would be indexed from 0 to 11 minus 1. So G is index 10. Right? So here we have an example where we're saying name and we're trying to index length of name, 11. Right? Well, name index of 11 doesn't exist. All right, we've walked off the end of the earth here and fallen off the edge. So we get an index error. Index error, string index out of range. Okay. Now we try to access the last letter in our string a different way. We know that the last letter in the string is going to be its length minus 1. So we can say that. Name sub length of name minus 1. This will give us 10. And voila, there's G. Right? The last letter in our string. Now, there's a shortcut to this. If you want to grab the last letter of the string, you can say name minus 1 and you get G. Okay, now you may be a little confused saying, well, a moment ago I told you that you can't edit a string. You can reassign it, but you can't edit it. And now I'm talking about accessing pieces of it, right? And any piece of a string is referred to as a substring. When you use a single index, you access a single character substring. And we'll see that there are ways to access multiple character substrings as well. So what's the difference? Well, the difference is that accessing any of these characters does not change the string. Notice that from the beginning, when I assigned Alan Turing to name, all right, I have carried out all these variety of access operations, and name has remained the same. In fact, if we were at this point to enter name into the shell, we would see that name is still assigned the value of Alan Turing. And in fact, because strings are immutable, the only way we have of setting name to something else is not by editing the string, but by simple reassignment. I could say that now name is assigned the value of ch04n6to9, in which case it would no longer point to Alan Turing, the cell that contained that in memory, but it would point to ch04n6to9. Okay, so the subscript operator is actually quite useful, especially if you want to use the characters in the string, or for some reason you're doing something based on the positions of the characters in the string. In other words, their index. In fact, because all strings are indexed using this zero-based indexing scheme, you can use a count control loop to process them. Here's a little example. We have data is assigned the value of hi there, so the same string that we looked at earlier. And now we're going to try a for loop for index in range length of data. Right? So let's examine the header first. What is this index? Is there something holy about the name index? No. It's a simple control variable, just like the control variables you've been using. But remember, we do the sensible thing, and we give the control variable a name that reflects how we're using it. So in this case, it's quite handy to use the word index. Another control variable name that you'll see quite often in a for loop is I. I would just be short for index. So for index, we're going to walk through each index in the string from 0 to the last letter. So we have for index in range. And what do we use as our limit? Length of data. So now you might be saying, oh, wait a minute, won't that walk off the edge? Well, remember, how do we use the range expression? The range goes up to, but not including, this value. So it's going to give us exactly what we want. We have a string here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters long. So range will length of data will resolve to 9. So for index in range 9. Therefore, the index each time through the loop will have the value 0, 1, 2, 3, 4, 5, 6, 7, 8, up to, but not including the 9, that is length of the data. So you see how nicely we can walk through all the letters in the string using this pattern with a for loop. And of course, in the body, we're printing both the index and the letter found, the character found at that index. Now here, your author tends to use this catch-all name data. And I would prefer in this particular instance that you would use a more meaningful variable name, such as CHR, short for character, right? Or CHAR, anything like that would make a lot more sense and would be a big plus for your internal documentation. sorry about that, in conjunction with the subscript operator. So what you would do inside the subscript operator is you would place a colon, and then you could have an integer value appear on either side of the colon. So how does this work? Let's look at an example. We have here name is assigned the value of a string myfile.text. Now this could actually be the name of a file on your system, myfile.text. If I wanted to look at just the string itself, there are several ways to do it. Number one is I could say name and give it the value 0 to start, and colon. If you give it 0 colon nothing, it starts at 0 and then it picks up or accesses all the letters up to the end of the string. So this would be a way to access the entire string. And if I wanted to, for instance, copy this name somewhere else, there's several ways I could do it. I could say, my new string is assigned the value of name. Another way of doing it would be my new string is assigned the value of name, subscript operator 0 colon right brace. Notice that that would create a new string, but my original string, name, would be unaffected. So here's the example where we enter name. Inside the subscript operator, we have the slice expression 0 colon. And we can see that if entered in the shell, it will come back with myfile.text. In point of fact, you can actually say name nothing colon nothing and still get the entire string. So there's actually several ways of getting the entire string if you so choose. If you just want to get one character, here we're getting the first character. We're going to start at 0. And after the colon, we're going to go up to but not including 1. And that gives us M. So notice again that we have the same pattern where the first value is the starting value, but the last value is the limit. All right, and you have to basically subtract 1 to get the bound. All right, so if I go from index 0 to 1, it's saying access 0 and then access any other characters up to but not including the 1. So that excludes anything after the M. And you see the shell returned the value M as we expected. Here we're saying start at 0 and access the string up to but not including index 2. So 0, 1, up to but not including 2 gives us my. Here we have pretty much the opposite of the expression here, and notice it accesses the entire string as well. Name, and now we don't have a starting index, we just have the colon, up to but not including length of name. It gives us the entire string again. If I were to have here name colon -1, that would give me up to but not including the last character. So again, you can use that negative indexing as we saw with just using the subscript operator. Here, there's a different way of using the negative value. We're going to start at the character that is 3 away from the end. So T would be -1, X would be -2, T again would be -3. Right? So this is saying start with this and then go up to, since there's nothing here, by default it means up through the end of the string. So anytime there's information missing with respect to this, the slicing operator. On the left side, the default is 0. On the right side, it's the length of the string. So this is a way of getting the last 3 characters, txt. So the slice operator could be thought of in Python as the substring operator. Many languages have either a substring operator or a substring function or method. All right, now here's an unusual operator. I say unusual because it's the word in, and usually when we have a word, we think of a function, or later on we'll look at methods. But this is an operator, just like plus or minus or the subscript operator. So when you use this with strings, the left operand of the in operator is a substring. The right operand is the string that we're searching through. All right, and we'll simply return true if this string on the left, the substring, often called the target substring or target string, is somewhere in the string that is searched on the right, or false otherwise. So how does this work? Here we have a file list. Now remember, we looked briefly prior to this at what a list might appear as. We looked at lists of values produced by the range expression when converted to a list. Here we have a list of strings, right? So in fact, you'll learn in the future that a list is a collection of any kind of data, actually. In fact, we talked about a string being immutable, unchangeable. A list, in fact, is mutable. In other words, you can edit the content of a list. So we have this file list. It consists of 3. Okay, so we're going to access the different strings in this list using a for loop. One of the interesting things about a for loop, remember, if you recall, I said originally when we talked about the syntax that a for loop, you have for, control variable, in, and then some sort of sequence. And a list is considered to be a sequence type, right? A sequence of pieces of data. So we can actually verbalize this for loop for file name in file list. Notice again, we're using file name because that's what this list contains. Each of these is a file name. For file name as our control variable in this data structure, file list, and we'll walk through each one each time through the loop. So here we're adding a nested if statement. If, and here's our target string, point txt. All right, if point txt in file name. So if point txt is in the file name, as it is here when we go through the first time, we're going to print the file name. Notice that this is just a plain if, not an if-else or an if-elif-else. So if text or .txt is not in the file name, we don't do anything. So the first time through the loop, we'll find .txt in the string, and therefore we'll print file name. The next time through the loop, we'll examine my program.exe, and we won't find .txt in my program.exe, so we won't do anything. We'll just go up to the header again and continue on our way. And then finally, the last time through the loop, we will process your file.txt. .txt is indeed in this string, and we'll print it. All right, and so you can see that if we were to enter this in the shell, we would see my file.txt, your file.txt being printed out.